This is tutorial 5A question 1b. What are the possible region of convergence shape? We are given the following types of signals, and each of these sequence will have a different region of convergence. This is the shading of the ROC. This is the real part of Z and the imaginary part of Z. Those that are shaded, such as this, indicates that these are the region of convergence. Different sequence, for example, these are finite sequence. This is causal finite sequence, meaning that the x of n will start only from 0 and will exist only for positive values of n. N is 0 otherwise. So this is a causal sequence. A causal sequence will have this type of ROC. In fact, it is the entire z-plane except z equals to 0. This is the anti-causal sequence. It will exist actually only from x of -1, -2 up to negative infinity. If it is finite, then after some time it will become 0 values. So again, on top is a causal signal existing only on positive time, but after a finite n, the rest of the values are 0. Now, in the anti-causal sequence, the region of convergence is everywhere except z equals to infinity. In the two-sided sequence, meaning some values are at negative indexes of n and some are in positive value, but they all dies away after a certain fixed negative big N and certain positive big N. We call this three sequence finite duration sequence. And the first one is causal, second one is anti-causal, and third one is called two-sided. And they have this form of region of convergence. We'll explain the why later on, but now let us proceed with the second set of type of sequences. The second type is the infinite duration sequence. We have the causal infinite, meaning that the signal only exists from positive time. Nothing is at negative time, but it does not die away. It is an infinite sequence. The most famous example in our course, of course, is half of to the power of n for n greater equals to 0 for all n. And therefore, even as n goes to infinity, half to the power of n is not 0. Such a sequence has a region of convergence that is outside a certain circle. This is the origin, and only for the value of z outside, in this example we call it R, we will shade the region of convergence. What R2 later on is a position of a pole. So the value of R2 will indicate a pole position. And what you'll realize is that the region of convergence must be external to the pole. So for example, the pole could be here, could be here, could even be at the complex plane. But what you will see is that the pole will mark the radius where we can draw a circle, and only where z is outside this radius, then the series will converge. In the next question, we'll ask you why the region of convergence is external to the pole. Because in the second example now, we'll see that we have an anti-causal signal. In an anti-causal signal, the opposite is true. You have a pole, for example, you have a pole here, and the region of convergence is inside this circle drawn by the radius of the pole. So the difference is that when you have an anti-causal sequence, the region of convergence string towards the origin. While in the causal signal for infinite sequence, the region is external to the radius specified by the pole location. Now, of course, if you have the most complicated example where you have a sequence that goes to the left hand side and the right hand side and never dies, then you would expect that you have two types of region of convergence. Let's call the top one R2 first and call the bottom one R1. Now, if R2 is smaller than R1, such that these two regions of convergence can overlap, then we would form a ring where this shaded region is the only region of convergence that satisfy both sequences such that XZ exists. Now, the answer is if this region of convergence does not overlap, then there is no ROC, and then basically you have an empty set for region of convergence. If you have that, then basically you cannot find the Z transform of this sequence. So, in summary, we are interested in causal sequences and we are interested in finite duration sequences and infinite duration sequences, and each of these sequences will have a different type of ROC. There are two special cases. The easiest special cases is when xn is equals to delta. Well, what happens when you have the Z transform of the delta is 1? And since xz is 1 and is not being affected by any z, therefore the region of convergence is all of z. The other special case is like what we have just said. If R2 is greater than R1, therefore this circle is outside this circle. The shaded region of these two does not overlap, therefore it is an empty set. Okay, so this is question 1b, the 6 possible shapes of ROC plus these two special cases, making it 8 possible shapes of ROC. Thank you.